Okay, so we discussed about mechanical properties of materials yesterday. Okay, I hope all of you understood what are the different mechanical properties of materials. Till now,
Yes, sir.
you all must be confused. What are these properties? Why are we calling hardness separately? Hardness, what is this elasticity? మీకు ఈ డౌట్స్ అన్నీ ఉన్నాయి. Yesterday by discussing about the properties of materials, mechanical properties of materials, I hope all of you understood. And also నేను మీకు ఎక్కడైతే ఇంపార్టెంట్, వాట్ ఈస్ ద ఇంపార్టెంట్ ప్లేస్ వేర్ యూ హ్యావ్ టు మార్క్ అనేది కూడా నేను మీకు చెప్పాను. ఫర్ ఎగ్జాంపుల్, మన క్లాసెస్కి నార్మల్ క్లాసెస్కి డిఫరెన్స్ ఏంటంటే ఎవ్రీబడి విల్ టెల్ యూ ద డెఫినేషన్స్. Hardness is resistance to inundation. Elasticity is the material will regain its original shape after removal of load. Plasticity is the material will not regain its shape after the removal of the load. ఇలా జస్ట్ డెఫినేషన్స్ మాత్రమే డిస్కస్ చేస్తాం. బట్ మన కేసులో ఏమైంది, వీ హ్యావ్ సీన్ ద గ్రాఫ్స్. యూ హ్యావ్ అండర్స్టూడ్ ద గ్రాఫ్స్ థరోలీ, రైట్? ఇప్పుడు ప్లాస్టిసిటీ అంటే ఒక గ్రాఫ్ చూపిస్తే మీరు ఆ గ్రాఫ్ ఏంటి అనేది ఈజీగా చెప్పగలుగుతారు. ఫర్ ఎగ్జాంపుల్, if I show you a graph like this, I will draw a graph, simple graph. Tell me what is this graph is. What kind of material this graph is representing? I will give you options. Is this graph representing a plastic material or an elastic material
Plastic.
or an elastoplastic material or a brittle material?
Brittle material, sir.
What is this graph representing?
Plastic, sir.
Okay, plastic material, very nice. Okay, some people are telling plastic material, some people are telling brittle material, but the answer is elastoplastic. Why it is elastoplastic? Because if you see the graph from here to here, from O to A, the graph is going linear. Whenever the graph is going linear, here the angle is 45 degrees. That means this is representing elastic, because stress is proportional to strain. That means how much amount of strain is increasing, the same amount of stress is increasing. For example, if strain is increasing by some 2 units, stress is also increasing by the same 2 units. Here the stress is also increasing by 2 units. So that means stress is proportional to strain. So when stress is proportional to strain, that is represented by an inclined line. Okay, so all of you make a note. Ippudu meer wrong answer cheppina, no need to worry, because you answers, if you give wrong, there is no need to worry about it, because we always learn from our mistakes, right? So how ee horizontal line, this horizontal line, you very well know that horizontal line is representing plastic. Yesterday I told you the horizontal line will be representing plastic zone, because this graph is consisting of an inclined line and as well as a horizontal line. This graph is called as elastoplastic. So this is the difference. In the other classes you will only have the definitions, but we are understanding the actual engineering. What is actual engineering? Engineers always talk with respect to diagrams. We always talk with respect to graphs. So now you are also understanding how to study the graph also. By looking at the graph, you can easily tell what kind of material is that representing. Now shall I draw another graph? Will you try telling me?
Okay, sir.
Okay, what is this graph representing?
Plasticity, sir.
Very good, very good. You are representing, it is representing a plastic material. Okay, so if there is inclined line, it is elastic. If it is representing a horizontal line, it is a plastic material. Okay, so yesterday I also told you some important concepts. What are the important concepts is hardness, what kind of test you do; elasticity, what kind of test you do; plasticity, what kind of test you do; ductility, what is ductility, you know; what is brittleness, you know, right? What is malleability, you know, which are very very important. you also know what is toughness, right? And finally we understood what is strength. So these were the concepts which were covered yesterday. I hope all of you followed them very well, and I
Yes,
hope
sir.
all of you have taken the notes also. Okay, we'll move on to the next topic. See, uh, the difference in deep concepts and the difference in the concepts which are on the surface is, yesterday I told you, if you remember, the difference between ductility and malleability. Imagine, can anybody tell me what is the difference between ductility and malleability? What you understand the difference between ductility and malleability? Ductility, the material
One
will
more of thing.
the material will expand
Tiny
only
degree
in
of
one
class.
direction. The material will expand only in one direction, that is ductility. Malleability is it expands in
All
all the
directions.
directions. If you forget, always try to imagine malleability. Chapati, how you make chapati? You make some thick paste and then you roll it. You remember, you roll that thick paste, అలా థిక్గా ఉన్నదాన్ని రోల్ చేస్తాం కదా మనం. రోల్ చేసినప్పుడు అది రౌండ్గా స్ప్రెడ్ అవుతుంది కదా. That means this is expanding in all the directions. Yes or no? So,
Yes, sir.
so here the atta flour is having malleability property. That is why it is expanding in all the directions. Following all of you. So that property is called as malleability. So for an element or for a member or for a object or a material to have malleability, you should have what? You should have plasticity property. You should have certain amount of plasticity, but strength is not required. But whereas for ductile material you should need a certain degree of plasticity undali and strength kuda undali. Endukante when you start pulling this, certain point it will break, it will have a crack here. Okay, so you need to have certain plasticity and also you need to have certain strength. So these are the major concepts or very important concepts that we have seen, especially when we talked about the mechanical properties of materials. Now in today's class we will talk about what is stress, what is strain, how do you relate stress and strain, and the most important one is the stress strain curve of mild steel, which is very important for your reset point of view. So in the yesterday's topic you are going to get 2 marks for your reset. So why am I telling the deep concepts here is 2 marks we should not lose. అంటే ఒకవేళ మిమ్మల్ని ఓన్లీ బేసిక్ డెఫినేషన్ అడిగారంటే యూ కెన్ ఎనీవే ఆన్సర్ ద బేసిక్ డెఫినేషన్. ఇఫ్ దే ఆర్ ఆస్కింగ్ యూ ఇన్ డెప్త్ క్వశ్చన్స్, that also you can answer. So our preparation is we are covering the topics in all possible dimensions. Following, we are not leaving it somewhere, we are not just going by the basic definitions, we are covering it in all possible aspects, because these 2 marks are also very important for us in the ESET. If somebody is getting 1 mark ahead of you also, the rank will change. Yes or no? So we are preparing such that we are not going to afford to lose these 2 marks also. Okay, so that is our way of preparation. In the beginning I told you our preparation will be at this level. ESET preparation is required up to this level, but we are preparing up to this level so that nobody can reach us, nobody can cross us. That is the strategy that we are preparing, and because you are preparing to this level, it will be useful for your job also. So try to understand the concepts, try to feel the concept, try to yesterday I gave you some examples related to our daily family issues. You remember, some people, I told you toughness means you had a fight with your friend in the evening. After you went back home, you had a fight with your parents. After some time you had a fight with your brother. So though you were having fight in a consecutive intervals of time, even then if you are able to take up that stress, that means you are not reacting, you are trying to put patience, you are cool enough. ఇంతమందితో గొడవ జరిగినా కూడా, మీకు పొద్దున్నే మీ ఫ్రెండ్తో గొడవ అయింది, మళ్ళీ ఇంటికి వచ్చిన వెంటనే మీ పేరెంట్స్, మీ మదర్ ఏదో అన్నారు, మీ మదర్తో సమ్ గొడవ అయింది. అట్ ద సేమ్ టైం కొద్దిసేపు అయ్యాక మీ సిబ్లింగ్తో గొడవ అయింది, తమ్ముడితో కానీ చెల్లితో కానీ గొడవ అయింది. ఇంతమందితో తర్వాత ఇంకేదో బ్యాడ్ న్యూస్, రిజల్ట్స్ వచ్చాయి, సమ్ బ్యాడ్ న్యూస్, బట్ స్టిల్ యూ పుట్ దట్ పేషెన్స్, కామ్ అండ్ పేషెంట్గా ఉన్నారనుకోండి, దెన్ యూ విల్ బీ కాలింగ్ యాజ్ tough. You're a tough person antam, because yesterday I told you, you remember, toughness is because of which kind of loading? cyclic loading. I told you
Yes, sir.
it is because of cyclic loading. What is cyclic? Repeated loading. ఓకే, సో సైక్లిక్ లోడింగ్ మీన్స్ రిపీటెడ్. అంటే ఇందాకే పొద్దున్నే ఫ్రెండ్తో గొడవ అయింది, సరేలే అనుకునే లోపు ఈ లోపు మళ్ళీ ఇంటికి వచ్చిన తర్వాత దేర్ ఇస్ సమ్ ఇష్యూ విత్ యువర్ మదర్, అండ్ దెన్ ఇన్ సర్టెన్ డ్యూరేషన్ అగైన్ ద సేమ్ డే, బట్ స్టిల్ యూ ఆర్ ఏబుల్ టు కీప్ యువర్ ఫేస్ విత్ అ స్మైల్, యు ఆర్ ఫైన్ ఇనఫ్, దెన్ యూ విల్ బీ కాల్డ్ యాజ్ అ టఫ్ పర్సన్. అంటే మన లైఫ్లో ఎన్ని కష్టాలు వచ్చినా కూడా మీరు ముందుకెళ్ళారనుకోండి, దట్ ఈస్ కాల్డ్ యాజ్ టఫ్నెస్. ఓకే, సో టఫ్నెస్, దట్ ఈస్ వై ఐ టోల్డ్ యూ సైక్లిక్ లోడింగ్. ఇప్పుడు మీరు ఎప్పుడైనా సరే ఆబ్జెక్టివ్ క్వశ్చన్లో టఫ్నెస్ ఈజ్ బికాజ్ ఆఫ్ 4 ఆప్షన్లు ఇచ్చారనుకోండి, మీరు ఖచ్చితంగా సైక్లిక్ లోడింగ్ ఆప్షన్ పెట్టగలుగుతారు. ఎందుకంటే ఐఎమ్ టెల్లింగ్ యూ అన్ ఎగ్జాంపుల్ రిలేటెడ్ టు యువర్ ఫ్యామిలీ మ్యాటర్స్, అవర్ డైలీ లైఫ్. These are the examples which are related to our daily life. So you will be easily able to pick the right answer. That is the reason why I am connecting our engineering with our daily life, so that you can easily pick the answer whenever you get a question. Okay, because in the future next we are going to study about surveying, we are going to study about R.C.E, we are going to study about hydraulics. There are many more subjects that are coming in our way in the future. So once you start preparing, there is a possibility of forgetting what happened in the previous class. Yes or no? మనం ఇన్ని సబ్జెక్ట్స్ చదువుతున్నప్పుడు ముందు ఏం జరిగిందో మర్చిపోయే అవకాశం ఉంది, కానీ ఎప్పుడైతే నేను ఇటువంటి ఎగ్జాంపుల్స్ ఇస్తున్నానో దెన్ యూ కెనాట్ ఫర్గెట్ వాట్ ఈస్ రిలేటెడ్ టు వాట్. ఓకే, రైట్. సో నౌ వీ విల్ మూవ్ ఆన్ టు అవర్ టుడేస్ టాపిక్, విచ్ ఈస్, somebody has unmuted, please mute your call. Simple stresses and strains. So we are going to talk about simple stresses and strains. So how do you define stress? How do you define stress? Stress, when will you get stress? I will give you a simple example. You wanted to go to a birthday party of your friend in the evening today. You went and told that to your mother. You asked some for permission. She did not permit you. What she told is, no, you are not going to any party, you are getting less marks, you have to prepare for the exams, take out your books and keep studying. This is what your mother said. How will you react? You will immediately go into the room, you slam the door, గట్టిగా డోర్ వేసేస్తారు, you start crying, right? గట్టిగా బయట కినపడేలాగా you start crying. So what is that? You started, you are in a state of stress. Why did you come to a state of stress? Because of your mother's reaction. So if your mother doesn't react, you went and asked your mother, Amma, today I am going to my friend's birthday party in the evening. Then your mother said, okay, go come at whatever time you want. Then అప్పుడు రూమ్లోకి వెళ్ళటము లేదు, no slamming of the door, no crying, nothing, no stress. That means stress will develop only when there is a reaction. So stress is because of reaction, stress is not because of action. That means now I will come to our subject. When a member is acted upon by a load, the member will start giving reactions. That means the molecules which are present inside, or the particles which are present inside, or the particles with which the object is made up of, they will start giving reaction. Okay, why will they start giving reaction? Because this material does not want to deform. The material does not want to deform. That is the reason why it will start giving reaction. So when it starts giving reaction, then reaction will lead to what? Stress. So now how can you define stress? Stress is the resistance. Stress is the resistance offered by the body against deformation. Understood all of you? Because the body does not wants to deform, it will start fighting the load, it will start giving reaction. So while giving, in the process of giving reaction, it will develop stress. Okay, so that is how you define stress. So stress is action or reaction? Stress is action or reaction? Tell me.
Reaction.
So
Reaction,
stress
sir.
is reaction. So stress is denoted by reactive force per unit area. It is not force per unit area, it is for reactive force per unit area, reaction per unit area. Got it? Following all of you? So ikkada force anesariki you should not take the action, you should take the reaction. Okay, so what are the different kinds of stresses? I hope all of you understood the stresses, right? The definition of stress is clear.
Yes, sir.
The next one is types of stresses. Types of stresses. What are the different types of stresses? Number one, normal stress. Normal stress. Normal stress lo malli two types. Tensile stress. Second one is compressive stress. Okay, and the next type of stress is shear stress. Shear stress or shear stress ni inkokati em antamante tangential stress antam. Tangential stress. So normal stress ante enti? Imagine there is a cylindrical rod, you are pulling it, you are applying a load here. So when you are pulling a rod, obviously it will undergo some stress. So what is that stress called as? That stress is called as normal stress. Why are you calling it as normal stress? Because this stress is acting along the axis of the member. This stress is acting along the axis of the member, you call it as normal stress. Okay, so here this object is undergoing a pull, so it will be tensile stress. If the same load is applied in the opposite direction like this, then this will undergo compressive stress. Okay, next one is shear stress. Shear stress is, this is developed when the load is applied perpendicular to the longitudinal axis. So when the load is applied perpendicular, then shear stress will develop. For example, there is a plate like this. I want to join two plates. There are two plates. I want to join these two plates. Okay, what I did is I kept a bolt here. Okay, now I am applying a force, pulling force P. Okay, I am applying a pulling force P. Now what happens, or what is the kind of load, or what is the kind of stress these two plates are undergoing? What is the kind of stress these two plates are undergoing? Can anybody tell me? You understood the question?
Normal stress.
Normal stress, very good. Okay, normal stress, again you have subclassification, tensile and compressive. Which one?
Tensile, sir.
Very good, excellent. So these two plates are undergoing tensile stress, but there is one more element here, the screw or the bolt. There is one more element, right? There is a bolt here, right? What is this bolt undergoing? What kind of stress is the bolt undergoing? It is undergoing shear stress.
Yes.
Because if the plates are very strong and the bolt is weak, the probability that the bolt will split into two halves like this. Yes or no? The bolt will crack into two halves like this, and the plates will come off. The plate will come off. Okay, so it is split into two halves. So because the stress is acting on the surface like this, because it will split like this, you are calling that stress as shear stress or tangential stress. I hope all of you understood this example.
Yes, sir.
Okay, so shear stress, normal stress, and the next kind of stress is bending stress, and the next one is bending stress. What is a bending stress? Bending stress means, I told you, whenever you bend a book, the top layers will be under compression, the bottom layers will be under tension, right? Top layers under compression and the bottom layers are under tension. So the top layers are under compression, bottom layers are tension. These forces have come because of bending. If you take a beam like this, if you apply a load, what happens to the beam? The beam will start bending like this. So what happens to the top layers? For example, AA dash and BB dash. AA dash will be undergoing compression, BB dash
Sir,
will
a
be,
picture madhula petra.
okay. AA dash will be undergoing, now this is fine?
Yes, sir.
Okay. AA dash will be undergoing compression, BB dash will be undergoing tension, right? So here this compressive force and this tensile force is coming because of whom? Because of whom? Because of this load W. So this load is causing the beam to bend, and that bending is causing the top layer to undergo compression and the bottom layer to undergo tension. That means the compression and tension that is coming in this beam is because of bending. So the stresses coming in the beam are now called as bending stress. Understood?
Yes, sir.
Right. And the next one is twisting stress. Imagine, okay, all of you now look at me. There is a beam like this. Can you all see me?
Yes, sir.
There is a beam like this and there is another beam like this. One beam is like this and the second beam is like this. Okay. So this beam will bend and also this beam will bend like this. Because there is a joint between these two, E beam ki ikkada joint undi. So when this beam is bending, automatically because of the joint, this beam will undergo twisting like this. It will undergo twisting like this. Following all of you? Twisting. So twisting will also cause shear stress. Twisting will also cause shear stress, because see what happens in twisting. The cross section of the beam will be like this. Because of twisting, the cross section of the beam will turn out to be something else, something like this. Ante first cross section ABCD ila undi, ippudu emaindi? The cross section has changed to A dash, B dash and C dash. That means some angle, there is a deformation in form of an angle. Following. So twisting stress is also a type of shear stress. Remember this, guttu pettukondi. I hope all of you understood. I will explain the twisting stress more in detail when we talk about the elastic constants. When we discuss about elastic constants, then also I will talk about this twisting stress or the shear stress again. I think now also you understood a bit, but there again second time we will discuss it. So now I am not stressing too much on it. Now we will move on to the next stress, that is bearing stress. Have you ever seen punching machine?
Yes, sir.
Paper punching machine. Files pettukodaniki papers ki punch kodtama మనం.
Yes, sir.
Holes la కొడతారు కదా punching machine తో. So what is happening there? You are putting the paper in between the punching machine and you are punching it. So when you are punching it, because the thickness of the paper is not sufficient to resist that punching force, the hole is forming. The thickness of the paper is very less. Paper chala sannaga undatam valla, when you have applied that punching force, paper madhyaloంచి కన్నం పడిపోయింది. అదే ఒకవేళ పేపర్ చాలా దెలసరిగా ఉందనుకోండి, ఇమాజిన్ యూ యూజ్ ద సేమ్ పంచింగ్ మెషిన్ ఇన్ ద కేస్ ఆఫ్ అ థిక్ ఐరన్ ప్లేట్. విల్ దట్ పంచింగ్ మెషిన్ వర్క్ ఆన్ ఐరన్ ప్లేట్? It will not work on an iron plate, right? Paper punching machine will not
Yes,
work
sir.
on an iron plate, because iron is having more elasticity and iron is having more strength, so punching will not happen. That means the paper could not bear the punching stress, whereas the iron plate could bear the punching stress. Understood all of you? So
Yes,
punching
sir.
bearing stress అందరికీ అర్థమైంది కదా, భరించడం. బేరింగ్ మీన్స్ భరించడం. ఓకే, పేపర్ ఆ పంచింగ్ ఫోర్స్ని భరించలేక కన్నం పడిపోయింది. అదే మీరు ఇఫ్ యూ పుట్ అన్ ఐరన్ ప్లేట్, యూ కెనాట్ create a hole there. I hope all of you understood.
Yes, sir.
Okay, so these are the different stresses. These are the different stresses, names of stresses. I hope all of you understood the different types of stresses: normal stress, shear stress, bending stress, twisting stress, and bearing stress. And you also understood the definition of stress. Now we will move on to the next item called strain. Shall we?
Yes, sir.
So the next one is strain. Very, very important one. So how do you define strain? Okay, before going to strain, the one important thing is, how do you measure stress? What are the units of stress? Units of stress, very, very important. What are the units of stress? In SI system, there are three systems, you know: SI system, System International, you have NKS system, right? And you have CGS system, three systems. But majority of the time we are using SI system. So according to SI system, stress is represented in Pascal. Stress is represented in Pascal. So 1 Pascal is equals to 1 Newton per meter square. Okay, 1 megapascal is equal to, mega ante 10 to the power of 6 Newton per meter square. Okay, 1 kilopascal equals to 10 to the power of 3 Newton per meter square. 1 gigapascal GPa is equals to 10 to the power of 9 Newton per meter square. Among all of this, the most important one is megapascal, because 1 megapascal is also termed as 1 Newton per mm square. Newton per mm square అని కూడా అంటాం. So among all these representations, megapascal is important. Give a heart to it. Okay, understood? So these are the units of stress. Now we will move on to our concept strain.
Sir, wait, note చేసుకుంటున్నాను.
నోట్ చేసుకోండి, అందుకే డిలీట్ చేయలేదు. You can note it down if you want. Now shall I move it a bit? Noted, huh?
Yes, sir.
Okay.
Yes, sir. 1 minute, sir.
Okay.
Continue, sir.
Okay. Strain. Strain is the measure of deformation. It is the measure of deformation. So when an object or when a material is undergoing a pull or a push, the material will try to deform. So what is the deformation that has come in that material? You will measure it in the form of strain. I will clearly explain you. You got bitten by an bee. మిమ్మల్ని ఒక కందిరీగో ఏదో ఒకటి కుట్టింది అనుకుందాం. Then what happens? Next day your hand will get swollen up. For example, it bit you somewhere here, your hand will get swollen up now. So what happened is, after certain time, pain వెళ్ళిపోయింది, pain పోయింది, there is no pain, but there is, the swelling is still there. So when you go to class, when you go to college, when you sit beside your friend will definitely ask you, ఏమైందే చెయ్యికి అని అడుగుతుంది, what happened to your hand? Because she can clearly see that your hand has swollen up a bit, she will ask you what happened to your hand, right? So now if you fell somewhere, okay, లోపల గనక మీకు పెయిన్ వచ్చేలాగా ఏమైనా దెబ్బ తగిలింది అనుకోండి, okay, Then when you go back to your class, will your friend ask you what happened?
No, sir.
Your friend will ask only when she sees that స్వెల్లింగ్ కనిపించినప్పుడు మాత్రమే అడగగలదు ఏమైంది అని అడుగుతుంది. అదే మీకు నొప్పి వస్తుంది కానీ బయటకు కనిపించట్లేదు, ఎక్స్పాన్షన్ వాచినట్టు ఎక్కడ లేదు, బట్ యు ఆర్ స్టిల్ ఫీలింగ్ ద పెయిన్. ఫర్ ఎగ్జాంపుల్, ఇఫ్ యు ఆర్ ఫీలింగ్ స్టమక్ పెయిన్, ఓన్లీ ఇఫ్ యూ టెల్ యువర్ ఫ్రెండ్ విల్ అండర్స్టాండ్ దట్ యు ఆర్ హ్యావింగ్ స్టమక్ పెయిన్, బట్ షీ కెనాట్ tell or she cannot ask you what happened. Yes or no? But swellings if they see, they will definitely ask you what happened to your hand, what happened to your leg, why is it seems to be a bit swollen up like that. So that swelling is called as strain, that which is nothing but deformation. The pain inside you, the pain is your stress and the swelling is the strain. Understood all of you? So this deformation is measured in strain. Okay, so if the strain is because of compression, imagine there is a small cylindrical rod. If you are applying compressive load here, length L, if it is undergoing compression, you call it as compressive strain. You call it as compressive strain. If it is undergoing pull, it expands, then you call it as tensile strain. So strain is attached, this name is attached by the nature of the force. If the force is pulling it, you call it as tensile strain. If the force is pushing it or compressing it, you call it as compressive strain. So you will just attach the name of the force in front of the strain and you will get the types of strains: tensile strain, compressive strain, shear strain, something like that. Okay, units of strain. Strain is a
No units, sir.
dimensionless quantity.
No unit.
Strain is a dimensionless quantity. So now you tell me which comes first, stress comes first or strain comes first?
Stress comes first.
Which one comes first?
Stress, sir.
But the answer is wrong. It is strain. Strain will come first and then stress comes. See, all our theories are based on strain compatibility. All our theories are based on strain compatibility. What is compatibility? What do you mean by compatibility? When do you become friends with a certain person? Only when you have compatibility, right? మీ ఫ్రెండ్, మీరు ఫర్ ఎగ్జాంపుల్ మీరు ఎక్కడికో బయటికి వెళ్ళారు, మీ ఫ్రెండ్కి చెప్పేసి వెళ్ళారు లేదా చెప్పకుండా వెళ్ళారు. సడన్ మీ పేరెంట్స్కి డౌట్ వచ్చి, లేట్ అయ్యావని డౌట్ వచ్చి మీ ఫ్రెండ్కి కాల్ చేశారు. ఫ్రెండ్కి కాల్ చేసినప్పుడు, అమ్మ అక్కడే ఉందా మా పాప అని అడగగానే ఏం చెప్తారు? ఇక్కడే ఉందా ఆంటీ అని చెప్తారు. సంథింగ్ లైక్ దట్. కంపాటబిలిటీ, యూ బోత్ హ్యావ్ కంపాటబిలిటీ. షీ విల్ కవర్ అప్ యువర్ మిస్టేక్స్.
Yes, sir.
దట్ ఈస్ వాట్ ఈస్ కాల్డ్ as కంపాటబిలిటీ. కంపాటబిలిటీ అంటే మీ ఇద్దరి మధ్య ఒక అండర్స్టాండింగ్. యూ బోత్ ఫీల్ దట్ ఫ్రీక్వెన్సీ మ్యాచింగ్. సో హియర్ స్ట్రెయిన్ కంపాటబిలిటీ మీన్స్ సో మీరు అక్కడ మీ మదర్ మీ ఫ్రెండ్కి ఫోన్ చేసినప్పుడు తన కవర్ చేస్తుందని మీకు ముందే తెలుసు. ఎందుకంటే యూ బోత్ ఆర్ జిగిరి దోస్త్. షీ విల్ డెఫినెట్లీ కవర్ యూ, షీ విల్ నాట్ బుక్ యూ. లేదా అంటే ఇక్కడికి రాలేదు, ఎక్కడికి వెళ్ళిపోయిందో తెలియదు అని చెప్పేసి అందు కదా, షీ విల్ డెఫినెట్లీ కవర్ ఫర్ యూ. సో సేమ్ థింగ్, ఇలాంటి సిచ్యువేషన్స్ మీకు జరిగే ఉంటాయి. యూ హ్యావ్ దట్ కంపాటబుల్ ఫ్రెండ్, రైట్? సో హియర్ ఇన్ ఆర్ సబ్జెక్ట్ స్ట్రెయిన్ కంపాటబుల్. ఇక్కడ ఏంటంటే, I told you in the beginning itself, we are doctors of structural element. We cannot find out whether that structural element is undergoing compressive stress. అందులో వస్తున్న పెయిన్ ఎంతో చెప్పలేదు. It cannot talk. Can the beam talk? Or can the column talk? Can the slab talk?
No, sir.
None of these structural elements can talk. But how will you find out whether the slab is in pain or whether the beam is in pain or whether the column is in pain? How do you understand? If you want to understand, there should be some compatibility. What is the compatibility? That is strain compatibility. You and the structural element, that means the doctor, who is nothing but ourselves, we are engineers, and the structural elements are having strain compatibility. Strain compatibility ante slab ganaka inta deflect ayindanondi, if the slab has deflected by this much amount, you will definitely say that okay, the slab is deflected this much, the slab is going to fail in the next 5 years. Okay, The column has buckled sidewise by this much amount. Okay, the column has buckled this much, that means the column is going to fail in the next coming years. So you are getting an idea about its failure by seeing the deflections, right? What are these deflections or deformations called as? Deformations are nothing but the measure of strain only. అర్థమవుతుందా లేదా అందరికీ?
Yes, sir.
సో ఇది ఎంత డిఫ్లెక్ట్ అయ్యింది అంటే ఇది కొన్ని రోజుల్లో పడిపోబోతుంది. Same thing, the steel rod has expanded this much, that means the steel rod is going to fail. The steel rod is in pain, the beam is in pain, the column is in pain. So the pain you are understanding by means of strain. What is the pain called as? Stress. So you are finding out the stress by means of strain only. That is why I told you, first comes strain, next comes stress. That is why you call it as strain compatibility. So if anybody asks you which one comes first or how are you finding out the stresses in the structural elements, you should say that is strain compatibility. The method is completely strain compatibility. Okay, understood? Understood? Shall we move on?
Yes, sir.
Right. So strain is a dimensionless quantity, you have no units to it. Now we will move on to the stress strain curve of mild steel. Stress strain curve of mild steel. Very, very important one. Give 3 hearts. Your little hearts. Stress strain curve of mild steel. Right. So first I will draw the stress strain curve of mild steel, and on the side we will discuss about the graph. So there are different types of steels. There is high carbon steel, there is low carbon steel, there is mild steel. There you have different types of steels. How are you classifying the different types of steels? All of you know there are different grades of concrete. There are different grades of concrete, M20, M30, M10, something like that, basing upon the strength of the concrete. Similarly, there are different grades of steel basing upon the carbon content, basing upon the carbon content. If there is high carbon steel is brittle. If there is medium carbon, medium or low, you call that is ductile, which is nothing but mild steel. Mild steel comes under low carbon steel. That is why you are calling it as mild. What is mild here? The carbon is mild here. That is why you are calling it as mild steel. So mild steel is an example of ductile material. So if you see the graph, I will just denote certain points. This is A, and then this is B, this point is C, this point is B. Okay, after C you have some horizontal line. Okay, and then you have D here, and then you have E here, and then you have F here. You have stress on y axis, strain on x axis. Do you know why is stress is there on x axis and why is strain on x axis? Stress on y axis and strain on x axis, why? Can anybody tell me? Can anybody tell me? Just now I told you which one comes first?
Strain.
Strain will comes first and then stress will come second. So that means stress is dependent on strain, right? Stress is dependent on strain.
Yes, sir.
So dependent variable will be on y axis, independent variable will be on x axis. So on x axis there will be independent variable, and on y axis you will have dependent variable. So stress is dependent on strain, that is why stress is coming on y axis. Strain is an independent one, that is why strain is coming on x axis. I hope all of you understood. చూడండి, ప్రతి దానికి ఫర్ ఈచ్ అండ్ ఎవ్రీథింగ్ యూ షుడ్ హ్యావ్ అ క్వశ్చన్ why should stress be on x axis, why should stress be on y axis, you need to know. If you see in your maths, y is a function of x అనే మనం వాడతాం functions లో. Y is equals to f of x. That means y is dependent one, x is independent one. Y is a function of x. So if x changes, y also will change. But if y changes, x will not change. X is not dependent on y, whereas y is dependent on x. That is why always on y axis you have dependent variables, on x axis you have independent variables. All of you make a note of it. Okay, right. I am erasing these because we will have a discussion on the right. Okay, so now you see this point is O, this point is O. So in the graph you have seen the mechanical properties in the previous class, right? Just pull it a bit so that you can see. Right, yesterday's class we have seen the mechanical properties, and you have very well know about these graphs. Graphs గురించి మీకు కొంచెం ఐడియా ఉంది, right? Okay, so here O to A, the line is a straight line. O to A, the line is a straight line. So O to A is a perfectly proportionality zone. Proportionality zone. Proportionality zone. What do you mean by proportionality? That means up to A, the stress is proportional to strain. That means however amount of strain is increasing, the same amount of stress is also increasing. O to A is perfectly proportionality zone. That means A is called proportional limit. అర్థమవుతుందా మీకు? A is called proportional limit. Now B is called elastic limit. B is called elastic limit. O నుంచి A వరకు the line is perfectly straight. You see here the line is perfectly straight, but from A to B the line is not straight. Here this portion the line is a bit curve, it is a small curve. So A to B it is not proportional, stress is not proportional to strain, but B is the elastic limit. That means even if you load at the point B, after you remove the load, the graph will trace back to the actual shape. The graph will trace back to the same shape. అర్థమవుతుంది అందరికీ? A is called the proportionality limit. Stress is proportional to strain only up to A. Stress is not proportional to strain from A to B. Okay, B is the elastic limit, A is the proportionality limit. Understood? B to C you have C is called upper yield point. C is called upper yield point, or you simply call it as yield point. So what happens at C, B to C there will be ductile extensions. What happens is you have ductile extensions. Ductile extension ante enti? What do you mean by ductile extension? Yesterday I told you ductility means it will start expanding without any increase in stress. the strain will start increasing. So B to C, you call it as ductile extension. Okay, the strain will start increasing drastically. B to C. Okay, na? Are you all following? Are you all
Yes,
following?
sir.
So B to C is ductile extensions will take place. C to D, if you see the line is horizontal, C to D the line is horizontal. So C to D you call it as a perfectly plastic or yielding zone. Okay, following all of you? Following all of you?
Yes, sir.
C2D you call it as perfectly plastic. What is perfectly plastic means? What is perfectly plastic means? Here what is expanding? What is increasing? Strain is increasing. Strain is increasing without any increase in stress. So here the extensions will be very huge. Almost the extensions will be 10 to times, 10 to 15 times, 10 to 15 times the extensions in the OA region. In the CD region, the extension of the rod will be almost 10 to 15 times the extensions in the OA region. Okay, so that is why C to D you call that region as perfectly plastic region or yielding region. Understood? So if you keep increasing the load, D తర్వాత మీరు గమనిస్తే the stress is increasing. D to E the stress is increasing. So D to E you call that region as strain hardening. Strain, just a second. D to E you call that region as strain hardening region. What is the strain hardening region? What is the strain hardening region? D to E, why is the stress value increasing? Why is the stress value increasing? What happens in D to E region is, now the steel rod which is undergoing extension, ఆ స్టీల్ రాడ్ ఏదైతే ఉందో ఆ స్టీల్ రాడ్ లోపల ఉన్న క్రిస్టలైన్ స్ట్రక్చర్, లోపల ఉన్న మాలిక్యూల్స్, నౌ ద మాలిక్యూల్స్ విల్ స్టార్ట్ గివింగ్ రెసిస్టెన్స్. దట్ మీన్స్ లోపల ఉన్న మాలిక్యూల్స్ కూడా రెసిస్టెన్స్ ఇవ్వడంలో పార్టిసిపేట్ చేస్తున్నాయి కాబట్టి ద లోడ్ ఈజ్ ఇంక్రీజింగ్ హియర్. దట్ ఈస్ వై there is some vertical movement in the graph. Whenever there is a vertical movement in the graph, that means the stress is increasing. Okay, till here from B to D there is no vertical movement of the graph, but whereas after D to E there is some vertical movement of the graph. You can see here, right? There is some vertical movement of the graph here. So why is this vertical movement of the graph coming? The vertical movement of the graph is coming because the atomic structure or the crystalline structure of the material, which material here? Steel rod is giving some resistance. So D to E region is called as, this region is called as strain hardening zone. That region is called as strain hardening zone. O to A is proportionality. O to B is elastic. B to C there are some ductile extensions, right? B to C. From C to D it is plastic region, right? From D to E it is strain hardening region. Following all of you? Following
Yes,
all of
sir.
you? So E is called as maximum stress point, ultimate stress. E is called as ultimate stress. Okay,
సార్ స్టక్ అయిపోయింది సార్.
ఏమైంది?
స్టక్ అయిపోయింది సార్ మీ వీడియో.
వీడియో స్టక్ అయిందా?
మీరు బోర్డు మీద రాసుకుంటే కనిపించట్లేదు.
ఓకే ఓకే, జస్ట్ a second.
రాకపోవట్లేదు. సార్ శ్రద్ధ అయిపోయింది సార్.
సార్ కంప్లీట్లీ ఆగిపోయింది.
ఒక్క నిమిషం.
సార్ శ్రద్ధ అయిపోయింది సార్.
ఆగొచ్చు కదా.
సార్ మళ్ళీ జాయిన్ అయినా అలానే వస్తుంది సార్.
ఎస్ సార్.
ఓకే ఓకే, ఒక్క నిమిషం అయితే ఐ విల్ సెట్ ఇట్, నో ప్రాబ్లం.
నా నచ్చిన పిల్లవే.
రాకేష్ should be left as a
శిరీష కనగల్ల ఇంటి రోజు
ఇప్పుడు ఎలా ఉంది? స్టక్ అయిందా? బానే ఉందా?
బానే ఉంది సార్.
నౌ ఇస్ ఇట్? అందరూ మ్యూట్ చేయండి. ఇప్పుడు ఎలా ఉంది? స్టక్ అయిందా? కనిపిస్తుందా?
కనిపిస్తుంది సార్.
కనిపిస్తుంది సార్.
కనిపించట్లేదు సార్.
మీరు కనిపించట్లేదు సార్.
ఓకే.
ఎస్ సార్.
ఇప్పుడు
కనిపిస్తుంది సార్.
కనిపించట్లేదు.
ఓకేనా? యాక్చువల్లీ నెట్ కనెక్షన్ కొంచెం ఫ్లక్చువేట్ అవుతుంది, అందుకని కొంచెం స్లోగా ఉంది. ఇప్పుడు ఓకే కదా? ఎవ్రీథింగ్ ఇస్ ఫైన్ నౌ?
ఓకే సార్.
ఓకే సార్.
ఓకే సార్.
Let's not waste time and we will quickly finish off. ఆల్మోస్ట్ ఎండింగ్కి వచ్చింది. ఓకే, సో స్ట్రెయిన్ హార్డనింగ్ జోన్ మళ్ళీ ఒకసారి నేను క్విక్ గ్రాఫ్ డ్రా చేస్తాను. The line is linear, elastic, proportionality limit. Point A, proportionality limit. Point B, elastic limit. Upper yield point. C is yielding point. From here you have horizontal D. After this D you have ultimate point E. From ultimate point you have failure point F. Okay, so O2A is called as proportionality limit. A is called as proportionality limit. B is called as elastic limit. That means if you remove the load after B, the curve will trace back to this shape. Same malle as it is ga, it will trace back to the same shape. But B tarvata ganaka meer loading cheste, B to C is called as which zone? B to C, what will happen? Ductile extensions will happen. B to C, ductile extensions will happen. That means B to C, the extensions will be very huge compared to the extensions in O to B region. B to C, there will be ductile extensions. Okay, C is called as yield point. C to B, C to D, you call it as plastic zone or yielding zone. Here the deformations will be almost 10 to 15 times the deformations in the OB region. 10 to 15 times the deformations in the OB. అంత ఎక్కువ deformations ఉంటాయి ఈ regionలో. D to E, you call it as strain hardening zone. Very very important. D to E, you call it as strain hardening zone. That means after D, if you keep loading it, the atomic structure or the crystalline structure of the material of the material will start giving reaction. That is why there is an increase in the stress here. It is giving resistance, that is why there is increase in the stress here. So after D, if you start loading, what happens is there is a concentrated plastic deformation. Following all of you?
Yes sir.
So what you are doing?
సార్ మళ్ళీ ఒకసారి చెప్పరా?
డి తర్వాత మీకు స్ట్రెస్ అనేది ఇంక్రీజ్ అవుతుంది. డి తర్వాత స్ట్రెస్ అనేది ఎందుకు ఇంక్రీజ్ అవుతుందంటే ద అటామిక్ స్ట్రక్చర్ అండ్ ద క్రిస్టలైన్ స్ట్రక్చర్ ఆఫ్ ద మెటీరియల్ ఈజ్ గివింగ్ రియాక్షన్. దట్ ఈస్ వై దెర్ ఈస్ అన్ ఇంక్రీజ్ ఇన్ స్ట్రెస్ హియర్. That is why there is increase in stress here. If you start increasing the load after ఈ తర్వాత కూడా మ్యాక్సిమం రెసిస్టెన్స్ ఇక్కడ వరకు ఇచ్చిన తర్వాత కూడా మీరు లోడింగ్ చేశారనుకోండి, ఇట్ విల్ అండర్గో అ క్రాక్ ఎట్ ద పాయింట్ ఎఫ్. ఎఫ్ ఈస్ కాల్డ్ యాజ్ ఫస్ట్ ఈ ఈస్ కాల్డ్ యాజ్ అల్టిమేట్ లోడ్. ఈ ఈస్ కాల్డ్ యాజ్ అల్టిమేట్ లోడ్ ఆర్ maximum stress point. Maximum stress point. F is called as failure point. Failure or fracture point. So after when you load after E, what happens is waste formation will occur. E nunchi F ki waste formation will occur. What is waste formation? In our body, how does waste look? Waste is the thinner version. So what happens is the steel rod, which is supposed to be like this, steel rod మీరు ఎక్స్టెన్షన్ మీటర్లో పెట్టకముందు ఇలా ఉంది, తర్వాత ఏమైంది? ఇదే స్టీల్ రాడ్, ద స్టీల్ రాడ్
స్టక్ అయిపోయింది.
స్టక్ అయిందా?
No, sir.
మీరు మాట్లాడలేదు.
The steel rod has taken this shape. Just a second. ఇలా ఉండాల్సిన స్టీల్ రాడ్ ఆఫ్టర్ ఇట్ ఈస్ అండర్గోయింగ్ ఎక్స్టెన్షన్ the steel rod will take a shape like this almost. That means here if you see there is a thin area, this is called as waste. So E నుంచి F మధ్యలో ఇంకా ఫెయిల్యూర్ అవ్వలేదు కానీ ఈ వేస్ట్ అనేది ఫామ్ అయిపోయింది. వాట్ ఈస్ దిస్ వేస్ట్? ద స్మాలెస్ట్ క్రాస్ సెక్షన్ that the steel rod will become, that is called as waste formation. So when the waste formation has done, even after the waste formation, if you are loading it, the failure will takes place. That means it will break. ఇక్కడ చూస్తారు కదా, కప్ కోన్ షేప్లో బ్రేక్ అవుతుంది. కప్ కోన్ షేప్లో 2 pieces కింద సెపరేట్ అయిపోతుంది అనమాట. సో దిస్ ఈస్ కాల్డ్ యాజ్ ఫెయిల్యూర్ పాయింట్. సో D to E you call it as strain hardening region. Okay, understood all of you?
Yes, sir.
ఓకే, సో ఈ నుంచి F వరకు ఏమైంది? ఇక్కడ సన్నగా అయిపోయింది. ఎప్పుడైతే సన్నగా అయిపోయిందో ఏరియా తగ్గిపోతుంది. ఏరియా ఎప్పుడైతే తగ్గిపోయిందో ద స్ట్రెస్ విల్ స్టార్ట్, ద లోడ్ విల్ స్టార్ట్ యాక్టింగ్ ఆన్ దిస్ ఏరియా. సో వెన్ ద లోడ్ ఈజ్ స్టార్టెడ్ టు యాక్టింగ్ ఆన్ దిస్ థిన్నెస్ట్ ఏరియా, further loading will cause failure or breaking of the structure. Okay, so I hope all of you understood what are these points. A is called as proportionality limit, B is called as elastic limit, C is called as yield point, D is called as strain hardening point, E is called as ultimate load or maximum load point, F is called as failure point. Understood all of you?
Yes, sir.
These are the different regions or different locations or different names of the points. How a mild steel, when the mild steel is kept in an extensometer in a UTM, how the failure will happen. This is how it is being explained. Okay, anybody has any doubts?
No, sir.
No sir? No sir?
No, sir.
Okay, so you understood in today's class what is the definition of stress, what is the definition of strain, right? What are the units, and then what are the different salient points in the stress strain curve of a mild steel. Okay, so if you don't have any doubts, we will continue in tomorrow's class.
Okay, sir.